radial arm saw is a versatile tool for woodworkers. Although it performs the same cuts as a table saw, including cross-cutting, ripping, miter, and bevel cuts, it operates in a different way. The radial arm saw cuts wood from above so you can see exactly what you're cutting. The motor and the blade, which are mounted on an arm above the table, are drawn across the wood to cut the boards to length. The radial saw is considered one of the better power saws for cross-cutting long boards. This program has been divided into the following segments. We'll begin with safety and follow with getting to know your saw, blade assortment, basic cuts, accessories, and projects you can make. While the radial saw is an exceedingly useful power tool, like all power tools, it can also be very dangerous if improperly used. Therefore, make sure you follow the general safety instructions. Keep the power off except when you're actually using the saw. Make sure the yellow key is removed and the switch is in the off position before plugging in the power cord. For your own protection, wear safety goggles whenever you're working around the machine. Don't wear loose clothing, jewelry, or watches. If you have long hair, tie it up or tuck it under a cap. And if you're using the saw for hours at a time, wear hearing protectors and a dust mask. Make sure your work area is clean and well lighted. And since woodworking can be messy, it's a good practice to clean up as you go along. Two major hazards connected with the radial arm saw are kickback and wrong way feed. Kickback occurs when the teeth of the blade grab and throw the workpiece violently back out of the saw. Kickback can also occur if you reach around the blade and try to pull the workpiece through the blade, or if the saw blade is pinched or bound by the workpiece. Wrong way feed can only happen when you're ripping. Wrong way feed is feeding the wood with the rotation of the blade, which is something you should never do. Wrong way feeding can pull the board and your hand into the blade before you can let go. It can also cause a board to be pulled through and thrown hard enough to injure someone. Always feed the wood against the rotation of the blade whenever you rip. The blade guard, the anti-kickback pawls, and the workpiece spreader are designed to reduce the risk of injury from blade contact, workpiece kickback, and wrong way feed. The blade guard serves as a partial barrier to help keep hands from touching the blade at the infeed end. It also helps keep the workpiece from lifting or fluttering during ripping and helps catch or deflect workpiece chips. The anti-kickback pawls help reduce kickback by grabbing into and holding the workpiece. The anti-kickback assembly provides some barrier protection from blade contact. Never feed the wood into the saw from the pawl side. The spreader helps keep the kerf of the workpiece open. Properly adjusted, it blocks the blade from being pinched and causing workpiece kickback. The spreader also helps reduce the chance of wrong way feed because it blocks the workpiece from contacting the saw blade. Always follow your saw's instructions to properly adjust the anti-kickback pawls for ripping. Read and follow the safety information and safety instructions in the operator's manual and on the safety labels on the radial arm saw. And know the location and function of all controls before using the saw. The location and operation of controls may differ among the various radial arm saws. For this demonstration, we're using the saw with an electronic measuring system. Your owner's manual will give you specific instructions for your make and model. If you have an electronic radial saw, use the electronic measuring system to adjust the bevel, miter, ref set, elevation, and rip settings. The on-off switch turns the power to the saw on and off. To turn the saw on, put the yellow key in the switch and then pull the switch to the right. To turn the saw off, push the switch to the left. It's a good idea to remove the yellow key from the switch whenever the saw is turned off. Keep the key in a safe place away from children. If the power goes off for any reason, always turn the switch off and remove the yellow key. If the switch is left on, the saw will start immediately when the power comes back on. The miter lock lever is used to lock the radial arm at various angles to the fence. To unlock the miter lock, pull the lever to the right. To lock it, push the lever to the left. There are 3 automatic index positions at 45 degrees, 0 degrees, and minus 45 degrees. You'll feel the radial arm snap into position at these miter positions. To unlock the arm and move it to one of these positions, pull the miter lock all the way to the right and move the arm. The bevel lock lever is used to hold the blade at various angles to the table. To unlock the bevel lock, move the lever to the right. To lock the bevel lock, move the lever to the left. There are 5 automatic indexed bevel angles at minus 90 degrees, minus 45 degrees, 0 degrees, 45 degrees, and 90 degrees. To unlock the bevel lock when the blade is at one of these angles, move the bevel lock lever all the way to the right. Always hold the motor when you unlock the bevel lock. Otherwise, the motor may swing down quickly, dropping the blade onto the table or anything else below it. Turn the motor while holding the lever in this position. The yoke swivel lock is used to hold the blade in the cross-cut, in-rip or out-rip positions, and to position the blade for molding or edging. To unlock the swivel lock, stand facing the saw handle and pull the swivel lock toward you. To lock the swivel lock, push the swivel lock away from you. When the saw arm is locked in the 0 degree miter position, the cross-cut, in-rip, and out-rip positions of the blade are automatically indexed. To unlock the swivel lock when the motor is in one of these positions, stand facing the saw handle, pull the swivel lock all the way toward you, and turn the motor as you hold the lock in this position. The RIP lock is used to hold the motor and blade at a fixed position along the radial arm. It's used during ripping to hold the blade a desired distance from the fence while the workpiece is fed through. It's used before and after each crosscut to keep the blade from moving forward on its own. To unlock the RIP lock, pull the handle toward the front of the arm. To lock the RIP lock, push the handle toward the rear of the arm. The hand wheel controls the height of the radial arm. To turn the hand wheel, pull the handle down. To raise the radial arm, turn the hand wheel clockwise. To lower the arm, turn the hand wheel counterclockwise. One complete turn of the hand wheel moves the arm 1/16 inch. The handle can be folded in by pushing the red button while pushing the handle in. Always lock the miter, swivel, and bevel locks before making a cut on your radial arm saw. When ripping, lock the RIP lock. When cross-cutting, lock the RIP lock before and after each cut when the saw is in its rearmost position. While adjustment and alignment procedures may differ among various radial arm saw models, the blade of your radial arm saw must be aligned properly in order to make accurate cuts and to prevent the binding of the blade and workpiece, which can cause jams or cause workpieces to be thrown. The specific instructions for doing the alignments for your make and model of saw are in the owner's manual. Now you're ready to install the blade guard and set the spreader. The blade guard and the spreader are very important safety features of your saw. The guard covers a large part of the blade and reduces the risk of injury. The spreader rides in the kerf of the cut wood during ripping and helps keep the two sides from pinching the blade and causing a kickback. Kickback, which can be very dangerous, can occur if the spreader is not in line with the blade. Setup, adjustment, and alignment procedures vary from model to model. The blade of your radial saw must be installed and aligned properly. The specific instructions are in your owner's manual. Blades are classified according to the different type of cutting they can do. This is determined by the size and shape of the blade teeth and gullets. The gullet is the gap in between the teeth. The blade that comes with the saw is usually a combination blade, which means it can be used for both cross-cutting and ripping. Cut-off blades have finer teeth than combination blades and are used for very clean cross-cutting. Ripping blades have wide chisel-like teeth that won't bog down when following the grain. If you use a lot of plywood, you might want to try the plywood blade. Its fine teeth don't splinter the workpiece. Carbide-tipped blades stay sharp much longer than the standard steel blades. However, they cost more. Blades should be reconditioned or discarded if they are dull, damaged with teeth bent or knocked off, warped or gummed. If your blade is cracked, throw it away. Your radial arm saw can be used for various crosscuts and ripping. It's especially known for its ability with crosscutting. Crosscuts are cuts made across the grain of the workpiece, and there are 4 basic types: a straight crosscut, a miter, a bevel, and a compound cut. Before making any crosscut with the radial arm saw, put your fence between the front table and spacer boards. Lock the table locks. Set the blade guard so its bottom is horizontal. Push the carriage to the rearmost position behind the fence and lock the rip lock. Make sure you lock the rip lock before and after each crosscut. Lower the radial arm until the blade almost touches the tabletop. Set the anti-kickback pawls and spreader to clear the top of the fence about 1/8 inch. In order to make crosscuts, you'll need to cut a table kerf, which is a shallow cut in the table, and a fence kerf, which is a slot left in the fence from sawing through it with the blade each time a new cutting angle is used. To make a crosscut kerf in your table and fence, plug the saw into a grounded outlet and put on your safety goggles. Insert the yellow key into the switch. Grasp the saw handle, keeping your forearm in line with the handle. Keep one hand on the saw handle at all times. The saw blade can suddenly come toward you when it's turned on. Turn the saw on. Turn the hand wheel another 1/2 turn more. This will let you make a 1/32 to 1/16 inch kerf in the table. Unlock the rip lock. Pull the saw blade forward through the fence and along the table as far as it will go. Return the saw blade to its rearmost position behind the fence. Turn the saw off, but don't let go of the saw handle. Wait for the blade to stop turning. Lock the rip lock. Remove the yellow key from the switch. You now have your table and fence kerf for 90-degree cross-cutting. To make a crosscut, make sure the saw blade is in the rearmost position behind the fence. Adjust the height of the anti-kickback pawls to clear the top of the fence and workpiece by about 1/8 inch. The anti-kickback assembly helps provide protection from the leading edge of the blade. Make sure your safety goggles are on. Position the workpiece along the fence to make your desired cut. Unlock the rip lock. Grasp the saw handle firmly. Since the saw blade tries to pull itself through the workpiece, be prepared to hold the saw handle back to keep the saw blade from coming toward you. Be sure to keep one hand on the saw handle at all times. Insert the yellow key into the switch and turn the saw on. Make sure that the hand holding the workpiece is at least 8 inches to the left of and out of the path of the saw blade. Support and hold the workpiece down and against the fence firmly with your left hand. Pull the blade through the fence and workpiece just enough to complete the cut. Return the saw to its rearmost position and continue to hold the saw handle. Turn the saw off. Wait for the blade to stop turning. Lock the rip lock. Remove the yellow key from the switch. A miter cut means cutting across the width of a workpiece at any angle other than 90 degrees, or a square cut. The radial arm saw has 3 indexed miter angles at 45 degrees, 0 degrees, and -45 degrees. You can also set the angle to any degree that you want. Because the blade can come completely off the table edge beyond the 30-degree left miter position, use the right miter position whenever possible to make miter crosscuts. Add a wooden extension to the left edge of the table whenever you must do left miters more than 30 degrees. To make a miter cut, first set the miter angle. In this case, we're setting it to 45 degrees. Then follow the same safety procedure as in making any crosscut. A bevel cut means sawing at 90 degrees across the width of a workpiece with the saw blade set to an angle other than 90 degrees to the table. In other words, the edge of the workpiece will be cut at an angle. Index the radial arm and yoke at 0 degrees. Set the bevel to the desired angle, in this case 45 degrees. Position the workpiece to be cut and hold it firmly against the fence. Then follow the same safety procedure as in making any crosscut. A compound cut is the combination of a miter and a bevel cut. In other words, the workpiece is being cut at an angle across the grain and an angle across the edge. For example, set the radial arm at 35.5 degrees and the angle of the blade at 30 degrees to produce this cut. The yoke is indexed at 0 degrees. Position the workpiece and hold it firmly against the fence. Then follow the same safety procedure as in making any crosscut. Ripping is used to change the width of the workpiece by sawing along its length. Rip cuts are usually made with the grain of the workpiece. There are two saw blade positions for making rip cuts, in-rip and out-rip. In the in-rip position, the motor is toward the front of the table and the blade is toward the fence. The in-rip saw position provides better visibility of both the workpiece and your hands than does the out-rip position. In out-rip, the motor is toward the fence and the blade is toward the front of the table. The only time you should use the out-rip saw position is when the workpiece is 14 inches or wider. You need to make a table kerf before a rip cut can be made. Every time you move the blade a new distance from the fence, you will need to make a new kerf. To make a rip cut table kerf, put the saw in the desired rip position, in this case 6 inches, and lock the rip lock. Make sure that the swivel, miter, bevel, and table locks are locked. Adjust the saw arm with the hand wheel until the saw blade almost touches the tabletop. Put on your safety goggles. Insert the yellow key in the switch and turn the saw on. Lower the saw blade until the blade touches the table. Turn the hand wheel about 1 full turn more. This will make a 1/16 to 1/8 inch kerf in the table. If your workpiece is 1/4 inch thick or less, make the rip kerf at least 1/8 inch deep to keep the saw blade from rising up on top of the workpiece and violently throwing it. Turn the saw off and remove the yellow key. After making the rip kerf, you'll also need to adjust the blade guard, anti-kickback pawls, and spreader. Your saw should be off to make these adjustments. To adjust the blade guard, put the saw in the in-rip position and lock the saw arm in the 0 degree position. Lock the rip, miter, bevel, swivel, and table locks. Go to the in-feed side of the saw blade. The direction of the rotation of the blade will be toward you. Put the workpiece on the table in line with the blade and under the nose of the blade guard so it touches the blade. Go to the other side of the table so you'll be able to loosen the guard clamp screw and rotate the guard until the guard nose just clears the workpiece. Tighten the guard clamp screw. Stay on the outfeed side to adjust the anti-kickback pawls and spreader. Put the end of the workpiece beside the blade and under the pawls. If the workpiece is unwieldy because of size or shape, substitute a piece of identical thickness and finish and continue as follows. Loosen the wing screw and lower the anti-kickback pawls and spreader until the spreader hangs next to the edge of the workpiece and the pawls on one side of the spreader rest on the workpiece. Tighten the wing screw. Go to the infeed side of the saw blade. If you have used a substitute piece, replace it with your workpiece and test it to be certain the anti-kickback pawls grab the surface and stop the kickback motion. On this piece, we're going to cut 6 inches, and the blade has been set 6 inches from the fence. Make sure the saw arm is locked in the 0-degree position and that the RIP, swivel, miter, bevel, and table locks are also locked. Insert the yellow key into the switch. Turn the saw on. Place the workpiece under the guard nose, keeping the workpiece edge against the fence. Place one hand flat on the workpiece and next to the fence. Place the other hand behind the first so that your fingers are on the back edge of the workpiece, out of the blade path, and as close to the fence as possible. Stand out of the line of the workpiece to be clear of it in case of kickback. You should be standing at the infeed end of the saw blade. You'll start and complete the cut from that same side. Begin the cut by pushing the workpiece, putting pressure on the part of the workpiece between the blade and the fence. If you push the part of the workpiece on the other side of the blade could be pinched and the workpiece could kick back. Keep pushing the section of the workpiece between the blade and the fence until the piece has been pushed completely past the anti-kickback pawls. Remember, do not pull, hold down, or touch the workpiece at the outfeed end of the saw. The blade guard does not provide complete protection at this point, and kickback or loss of a finger, hand, or arm could occur. When the piece has been pushed completely past the anti-kickback pawls, turn the saw off. Because the blade continues to turn for about 12 seconds after power is turned off, do not reach for the cut workpiece until the blade stops. Then remove the yellow key from the switch. When ripping, always set up the saw blade so the widest part of the workpiece is between the blade and the fence. For example, if you want to take 1 inch off an 11-inch wide workpiece, set the saw blade 10 inches from the fence. Don't rip 1 inch off an 11-inch workpiece by setting the saw blade 1 inch from the fence. When the blade is set between 2 and 6 inches from the fence, you should use a push stick. Otherwise, your hands will be brought too close to the blade. If your workpiece is long, make sure you have a supporting structure and don't try to support the piece yourself or allow anyone to help you. If the blade is set between 1/2 inch and 2 inches from the fence, you must use a push block and an auxiliary fence. When making rip cuts, don't set the blade closer than 1/2 inch from the fence or auxiliary fence. To make a bevel rip cut, set the saw in the desired position. Adjust the blade guard, anti-kickback pawls, and spreader. Index the arm to 0 degrees and lock in position. Bevel the blade to the desired angle and follow the same steps as when making a straight rip cut. There are various accessories that can be used with the radial saw that allow you to do a number of things. We'll be going over the use of the dado blade, the molding head, the drill chuck, and the sanding drum. However, before using any accessories, refer to your owner's manual for instructions. The dado head is a special saw blade. It makes a groove or a square-sided notch in the workpiece. It does not cut all the way through the stock. One type of dado head consists of a set of blades, typically 2 outside 1/8 inch blades and 5 inside chipper blades, 4 of which are 1/8 inch and 1 1/16 inch. By varying the combination of these blades, you can vary the width of the dado cut. A new Excalibur blade allows the changing of this width by dialing it in. The unit does not have to be removed from the arbor. When installing the dado on the arbor, always install the inside loose collar first to ensure good arbor nut engagement. Install the first blade. Make sure the cutting teeth are pointed to the direction of the rotation of the motor. Then put the chipper blades on, making sure that the cutting edge of the chipper blade is alongside a gullet in the inside blade. Space the chipper blades and then install the outside blade. Install the arbor nut directly against the outside of the dado. Since your dado cut will only cut part way through the workpiece, it's very important to adjust the height correctly. Some dado blades have marks on them for measuring. If yours doesn't, mark the workpiece and then by using the hand wheel, lower the blade. It's always a good idea to make a trial cut using a scrap piece of lumber. The dado blade can be used to make all kinds of cuts, including dados, which are cut across the grain, grooves, which are cut with the grain, and rabbets, which are dado cuts along the edge of your workpiece. The molding head is used to mold or shape edges. It has a number of different cutters in the standard molding shapes, which allow you to make decorative edgings as well as a variety of cuts. See your owner's manual or accessory guide for instructions on installing the molding head. To use the molding head, you'll need a fence that has an opening. Put your workpiece in position and then turn the cutter head by hand until one knife butts against the edge of the work. This way you can establish the knife height for a particular shape. Adjust the cutter so it will cut no deeper than 1/8 inch into the workpiece. This will give a smoother finish and help avoid kickbacks. Make repeated passes for deeper cuts. Lock the carriage. Install the guard and adjust it so it just clears the workpiece. Make sure your safety goggles are on. Insert the yellow key, turn the saw on. And holding the work flat on the table and snug against the fence, slowly cut along the edge until the end of the work passes the cutter. The drill chuck accessory lets you make all kinds of holes with your radial saw. To install the drill chuck, first take off any cutting attachments on the saw. See your owner's manual or accessory guide for specific instructions. To use the drill chuck, you'll need to attach an auxiliary table or fence. Clamp your workpiece with a C-clamp. Rotate the motor by loosening the yoke swivel and indexing it in the out RIP position. Lock the yoke swivel and turn the hand wheel to position the drill. Turn the on-off switch on and drill. To do end drilling or boring, put the motor in the crosscut position. Turn the on-off switch on and bore. The drum sander lets you use the saw as a sander. The sandpaper sleeves come in different grades from fine to coarse. To install the drum sander, first take off any cutting attachments on the saw. See your owner's manual or accessory guide for specific instructions. To do curved edge sanding or inside sanding, have the arbor shaft in a vertical position. You can use the radial saw to make a variety of different things, from a picture frame to a drawer. One of the simplest projects to make is a frame. A shadow box picture frame uses a number of different cuts. A compound cut provides the joint. You begin by making your molding, and then do your RIP cuts. Now you're going to make a compound cut with a 35.5 degree miter and a 30 degree bevel. Glue the joints, and you have a lovely shadow box frame. Another easy joint is the spline joint. It can be used to reinforce the miter. The first step in making a spline joint is to cut a 45 degree bevel on each workpiece. Then make a 45 degree spline cut. Then make the spline, and you have a spline joint. A lap joint can be cut by using a dado. When cutting a lap joint with a dado blade, you can make one pass or several passes. Another easy project is a bookcase. You use crosscuts to cut the boards to length. And you'll be making dado cuts so the shelves can just slide in. For the top, let's make a simple rabbet, which is a dado cut along the edge. Here's how it fits together. A drawer may seem complicated, but it's actually quite an easy project to make with the radial saw. Generally, the bottom is a piece of hardboard or plywood that you cut to length and width. Then use a dado head to cut the groove for the drawer bottom in the side, front, and back pieces. Check the groove size with the stock being used for the drawer bottom. Drawers can be joined with many different kinds of joints. On this flush drawer, we're using a rabbet joint. A few cuts, and your drawer is complete. With the radial arm saw, you have a power tool that allows you to rip, cross-cut, cut joints, drill, shape, and sand wood. By using your saw properly, and by following the instructions in your owner's manual, you'll have an efficient, versatile power tool you can use for years. In the second part of this tape, you'll learn how to use your Craftsman radial arm saw to make this handsome wall cabinet. You'll learn how to make different kinds of joints and perhaps master some new woodworking skills. For the purposes of this demonstration, we have pre-built the wall cabinet in several stages. This way, it will be easier for you to follow the progression as we go through it. Make sure you view this entire tape before beginning the project. We've also included printed project plans with this videotape. For this project, you'll need the lumber or stock listed on the bill of materials as shown here. This project is made with 1x6 pine lumber, with the exception of a plywood or hardboard back. In making this cabinet, we'll be using several Craftsman accessories, including a dust collector, an extension table that fits on the side of the radial arm saw, a convenient table cover that not only protects the radial arm saw table, but also includes handy charts, scales, and important safety tips. We'll also use a dado blade and a molding head with straight bevel cutters for panel raising. You should know that when using a molding head of this sort, a special molding and dado guard is a must. We will also be using a hold-down attachment for which you will need to make an auxiliary fence. The hold-down attachment comes with complete instructions for you to follow. The only other accessories we'll use are a drill press, a mortising kit, and a 1/4 inch mortising bit and chisel. The joint construction of the cabinet face frame is called cross-lap construction. This means that the faces of the two side stile boards overlap the faces of the horizontal rail boards. The face frame is completely assembled and glued together before being attached to the cabinet. The cabinet doors are raised panel doors designed to float within the door frame. The door frame is constructed of material ripped from 1x6 stock and connected with mortise and tenon joints. When using the radial arm saw to construct these panels, you must use two specially designed push sticks or shoes. There are complete instructions included with the panel raising bits on how to make these push sticks using glue and a few nails. Before we begin, note that all tenons are 1/4 inch and all lap joints are 3/8 of an inch. Refer to your drawings for more information and exact measurements. Also, if you don't already have a mortising attachment for your drill, simply change the door joint to a miter. To begin, cut the sides to length. Then cut the top, middle, and bottom shelf to length. An easy way to cut several boards to an identical length is to use a stop block. Take the measurement from your project plans and mark it on one of the boards. Line up the mark on your board with the blade and set a stop block on your extension table. Then cut the board to length. Put the next board against the same stop block and it will be cut to the exact same length as the first. Repeat a third time for the last board. Next, we'll work on the face frame. The first thing we need to do is rip the face frame boards to the dimension noted on your project plans. Before actually ripping, make sure that the anti-kickback pawls are set. After all face frame stock is ripped to width, you'll cut it to length. Refer to your plans for the exact measurement. Change the saw from rip mode back to crosscut. Adjust the anti-kickback pawls and cross-cut the face frame pieces to length. After making the two stiles, you will need to make 3 rails. Square off the first end of each piece. Mark the length, line the blade up to the mark, and set the stop block on the extension table so you will be able to cut the other 2 rails to exactly the same length. Put in the key, turn on the saw, and make the cut. Cut the other 2 rails in the same manner. The next step is to make lap joints in order to construct the frame. We will remove half the thickness of the bottom at the ends of the stiles and half of the top at the ends of the rails. You'll have to decide which faces you'd like facing out. Mark them with an X. You need to know this in order to decide where to make your cuts. Now lay out the lap joints. Mark the dimensions of the joints to mate with the width of the rails or stiles. Remember, the stiles lap on top and the rails go on the bottom. For your own reference, mark what portions you will remove of the stiles and rails. That way you won't be confused when you begin to cut. Keep in mind that the depth of the lap joint will be exactly 1/2 the thickness of the wood. That way, when they fit together, the joint is as thick as the original piece of wood. To cut lap joints, put the X-caliber dado onto the radial arm saw. The large arrow on the dado blade indicates the point at which the dado blade is at its maximum width. Line up the mark on your board with the arrow and position a stop block. To remove stock, make several passes through the wood. Do the same for all of the sections. Assemble the frame and glue the lap joints together. Now it's time to cut dados onto our side pieces. The middle shelf uses a full dado joint, which means the full width of the shelf. The top and bottom joints are standard dados. To make the dados, adjust the X-caliber dado blade to 3/8 of an inch and set the depth of the cut at 3/8 of an inch. You can do this by marking on the wood 1/2 the depth and 1/2 the thickness and adjusting the saw. Or you can use the saw's electronic depth measuring device by first zeroing the elevation with the blade at table level and then raising the blade until the proper elevation is displayed. Keep in mind that the side boards have dado grooves and the top and bottom boards have rabbet grooves. Mark the dado groove for the middle shelf, which you will cut later after readjusting the dado blade. Again, set a stop block. That way all of the dado grooves on the ends of each side will be at the exact same location. This will help you in keeping the cabinet square. When you've finished cutting the top and bottom dados on both side pieces, reset the stop block and set the width of the dado blade to 3/4 of an inch for the middle shelf dado cut. It's a good idea to make a few trial cuts on scrap to ensure that you've got the exact setting for the thickness of the wood. Next, make a rabbet on the sideboards, top and bottom to accommodate the back piece of plywood. Now we'll lay out and drill holes on the inside of the sideboards approximately 1/4 inch deep for the adjustable shelf brackets. Locate the holes as shown on the project plans. Center punch each hole and drill. Next, sand and clean the parts you've cut out. Cut the back to size before assembling the cabinet and sand to break the splintery edges. Glue and assemble the cabinet pieces and place the back in the rabbet grooves. Don't glue the back in place at this point. Just use it as an easy way to keep the cabinet square when clamping. After the glue is dry, you can remove the back for ease of finishing. When both the face frame and cabinet construction are completely dry, we can attach the face frame to the cabinet. Simply apply glue and place the face frame on the cabinet. You can also use screws, small brads, or blind dowels to attach the face frame, if you wish. Clamp in place while the glue is drying. Next, onto the doors. We're going to rip the wide board to 2 inches for the rails and stiles of the doors. Set the saw in rip mode. Have your push stick ready. Check that the anti-kickback pawls are properly adjusted and make sure the guard is in the proper position. Now to cut the groove for the raised panel. The groove is 1/4 inch in width and 3/8 of an inch deep. Tilt the arbor so that the blade is horizontal, as if working on edge molding. Cut the groove with the Excalibur dado blade. You must use a dado guard and hold-down device for this cut. The hold-down device provides maximum stability and safety. In order to use it, a special auxiliary fence is necessary. Plans for making this fence are included with the hold-down device. Now cut the grooved stock to the appropriate length for the stiles and rails. The next step is to cut a haunched tenon into the rails for the doors. We want to cut this joint at both ends so that the rails and stiles can be attached together. The haunch fits into the top side of the stile, which is opposite the side with the groove in it. This notch fits into the groove of the stile. Set up a stop block and mark the shoulder cut on both ends. Remember, you only need to mark one board if you set up a stop block. Make the first cut along the line. Pull the stock away from the stop block while holding the stock firmly and tightly against the fence. Make the second and third cuts. Flip the board over and perform the same procedure on both ends. Adjust the blade and finish cutting the tenons. Next, mark and drill mortises into the stiles to accept the tenons we just made. You'll need a 1/4 inch mortising bit and chisel in addition to the mortising kit. Pull down the stripper to hold the stock in place. The stripper should be adjusted so that it is just touching the wood. The wood should be able to slide back and forth. Set the depth stop to 1/2 inch, as noted in your project plans, and drill all mortises. Next, turn off the drill press and unplug it. Then insert the squaring chisel into the drill. Simply lower and raise the yoke to square off the mortise. Now make a trial assembly of the rails to the stiles. Next, we'll cut the raised panel for the door. The raised panel will be cut so that it floats within the frame of the rails and stiles. Cut the panel with panel raising cutter bits. To do this, you will need to make the auxiliary fence used with the hold-down device. Also, you must use the 2 specially designed push sticks or shoes. Make the special push shoes according to the instructions with the panel raising bits. Raise the auxiliary fence above the table surface to give you a guiding edge to follow. Always make the end grain cuts first. It takes 2 different push shoes to make these cuts. First cut one end, then cut the other end using the first shoe. Then change push shoes and do the 2 edges of the stock. Only take 1/16 of an inch off the panel at a time. It will take several passes to complete the operation. If you want to make rabbet cuts on the back face of the panel, do it prior to making the raised panel cuts. And if you do this, raise the RIP vents opening to compensate for the amount of wood removed by the rabbet. You can achieve the smoothest possible cut by lowering the cutter bit 1/32 of an inch on the final pass. That's a half rotation of the elevation knob. If you do this, you will minimize the need for extra sanding. Now make a trial assembly. Slide the panel into the stile and into the rail. After the trial assembly, glue and clamp them all together. Try not to get the glue between the panels and the stiles so that the panels can move freely. Measure and mark the location for the hinges and door pulls and mount them onto the cabinet. Then remove them and finish sand the cabinet. Stain or paint the cabinet and back piece. Nail or screw the back into place. Then reattach the hinges and door pulls, and your project is complete.